Alright, you have seen why a flood vector store hands back both London and Tokyo. This agent just told me the user lives in both London and Tokyo at the same time. One graph fixed it, and the fix is stupidly simple. You know that feeling when your agent confidently repeats something that stopped being true 2 sessions ago? That's not a prompt bug. Vector memory basically has no idea that one fact replaced another. It stores both and ranks them by similarity. The fix has been sitting in databases for decades. So Graphiti basically models memory as a knowledge graph. Every fact is an edge between two entities. Here is the part that matters. Each edge carries 2 timestamps, when the fact became true and when it stopped being true. So when a new fact contradicts an old one, Graphiti doesn't overwrite it. It flags the old edge invalid and keeps it. The model is the easy part. Those timestamps are where it gets interesting. So when you add a message, Graphiti runs it through an LLM to pull out entities and relationships. Then it checks new edges against existing ones. If 2 facts can't both be true, it closes the old edge with an invalid timestamp. Retrieval is hybrid. Semantic, PM25 and graph traversal together. Notice you get all of this without writing custom logic. It will make more sense once you see it in the code. Alright, you have seen why a flood vector store hands back both London and Tokyo. Let's get everything installed and running. One pip command pulls in Graphiti core, ChromaDB for the baseline, OpenAI for extraction and Python.env for loading secrets. For the database we don't install anything locally. Instead we run neo4j in Docker. This starts version 5.26 with bolt on 7687, which is the port Graphiti connects to. Now let's set our secrets. We create a .env file and we specify OpenAI API key, neo4j URI, neo4j user and neo4j password. Just make sure you match neo4j password with whatever you set in the docker command for neo4j. So before we fix anything, let's reproduce the actual problem in the vector baseline.py file. This is the naive setup most people ship. We spin up a ChromaDB collection and drop in 2 facts about Alice. First she lives in London and then she lives in Tokyo. And after that we ask Chroma where Alice lives. Let's see it in practice. Let's run the vector baseline. As you can see, it returned a distance for 0.3 for London and 0.47 for Tokyo. Even though they're different, they're quite similar and close to each other. And that's because Chroma has no idea Tokyo replaced London, so it treats them as equally true. And this is the stale contradiction from the intro. Alright, now we move to a new file called temporalmemory.py. We import Graphiti, the episode type in datetime for our timestamps, pydantic, and .env. And then we call load.env, so the .env values are loaded. We also mute a neo4j logger that screams a harmless index already exists error on every rerun, and now we define the types, and these matter more than they look. We define a person and a city class with pydantic. Here is the thing. Graphiti extracts entities and classifies them against the types you give it. If you only define person, the city never becomes a node, so there's nothing to connect and no relationship forms. Giving it both means both ends of the fact exist. The user becomes one node, the city becomes another, and the lives-in edge connects them. Now we wire up the connection. We read the neo4j credentials from the environment and hand them to Graphiti. Then we call build indexes and constraints. You only run this once per database. It sets up the vector and full text indexes Graphiti needs for that hybrid search we talked about. If you skip it, your first real query just returns nothing. Alright, let's give Graphiti its first fact. Alice lives in London, dated back in January. That reference time is the part people skip and it's what makes the memory temporal. Graphiti runs the text through an LLM, pulls out Alice and London and links them with a lives-in edge. And we print the counts right after. If that says 0 edges, extraction didn't connect anything, and you know something is off before you go further. So this second fact is the whole point. Alice lives in Tokyo now, dated in June. It's the same person and the same lives-in relationship, just a different city. When Graphiti ingests this, it notices Tokyo contradicts London. Instead of overwriting, it closes the London edge by stamping an invalid on it. The old fact doesn't get deleted. It just gets marked as no longer true. That one move is the entire difference from the vector store, and the print confirms a second edge came out. Alright, now we run the same kind of question that broke Chroma. We ask the graph where the user lives. The key part is what we print for each edge. For every result, we pull the fact plus its valid and invalid timestamps. Remember, this search is hybrid, so it's combining semantic, BM25 and graph traversal under the hood. And then we close the connection and the async IO guard runs the whole thing. Alright, this is the moment of truth. Let's run the file. Graphiti makes a few LLM calls to extract and resolve, so give it a few seconds. And here it is. As you can see, Tokyo comes with an invalid at set as none, which means that this is the current fact. You can also see that Alex lives in London has valid at and also invalid at, which means that the graph knows that Alice used to live in London but is no longer valid. This is the same data that confused Chroma, and now both questions have a clean answer. Alright, let's look at what you've got now. Your agent has memory that actually understands time. When a user updates a fact, the old one doesn't vanish and it doesn't stick around pretending to be current. It gets marked as past and you can still query it on purpose, so you can finally answer both questions. Where does this user live now and where did they live before? A flat vector store physically can't do that. Next step. Take an agent you have already built and swap its memory layer for this. Watch how many stale fact bugs just disappear. And if this helped, hit subscribe. I'll catch you in the next one.